Hello students, it is my lecture 4 of alcohols and phenols. I am Dr. Braja Bandhu Nanda. Today we shall discuss about the properties of alcohol 2 because in properties of alcohol 1 or in the lecture 3 we have discussed two of the chemical properties of alcohol due to cleavage of O bond H and due to cleavage of R bond OH. So, in this class, we shall discuss the properties of alcohol due to alkyl group and a OH group or alcohol as a whole. So, for that, we have to discuss about the acidic dehydration, oxidation, dehydrogenation, and the distinction between primary, secondary, and tertiary alcohols. Let us first discuss the third chemical reaction, that is the reactions involving alcohols as a whole. In this heading, we shall discuss the acidic dehydration of alcohols. Acidic dehydration of alcohols is an elimination reaction and is carried with concentrated sulfuric acid upon heating. A molecule of water is eliminated and an alkene is formed as the product. For the elimination reaction, the presence of a beta hydrogen in alcohol is necessary. I am just showing the example here. The alpha hydrogen contain OH group and alpha carbon contain OH group and beta carbon contain one hydrogen. The hydrogen of a beta carbon and the OH group of alpha carbon, they will combine together to form water, and this bond combine together to give a pi bond. So one sigma bond is already there between carbon and one pi bond is formed. So an alkene is produced when the dehydration of alcohol is taking place in presence of a concentrated sulfuric acid. When ethanol is reacted in presence of sulfuric acid, it will give ethene plus water. So here 95% sulfuric acid is required. If a secondary alcohol like propan 2-all is heated with sulfuric acid, then it requires less amount of sulfuric acid, that is equal to 60% of sulfuric acid, and the temperature is also lowered, that is equal to 373 Kelvin. So what will produced? So CH3CH double bond CH2, propene is formed plus water. Similarly, if a tertiary alcohol will be taken, then less amount of sulfuric acid and a lower temperature is required for the dehydration. So the OH group of 3 degree carbon and H atom of any methyl group will be removed to give a 2-methyl propene, which is given on the right hand side. So let us discuss about its mechanism, how the reaction occurs. The mechanism is illustrated with ethanol, which is a primary alcohol. You see the lone pair electron present on the oxygen atom of ethyl alcohol takes one hydrogen ion, H plus ion, from H2SO4. So as a result, it will form CH3CH2OH2 plus OSO3H ion. So this protonated ethanol, again, because it is unstable, therefore it loses water molecule in a slow manner to form CH3CH2 plus water. This carbocation which is formed here, ethyl carbocation, it will again lose one H ion, hydrogen ion, to form a double bond with this carbon containing positive charge. So what is produced? So ethene is produced. So the reaction takes place in presence of a bisulfate ion and sulfuric acid again regenerated. Since tertiary carbocation is maximum stable while primary is the least, the tertiary alcohols are maximum reactive while the primary are the least reactive in nature. We have seen that alkenes are formed by the dehydration of alcohol with concentrated sulfuric acid. A few more products may also be formed under this specific condition. If you take ethanol in excess, then what happens? Then one ether is formed. You see C2H5OH plus HOC2H5 in presence of a sulfuric acid at 413 Kelvin. It will give C2H5OC2H5 diethyl ether, or it is known as ethoxyethane plus water molecule. This mechanism is also given. So the ethanol which we have taken here, it takes H plus ion from acid and it forms carbocation. So ethyl carbocation is produced. That ethyl carbocation again reacts with another alcohol molecule. So what is formed? The protonated ether is formed in the third step, and that will lose another hydrogen ion or a proton to give diethyl ether or ethoxyethane. And next, the reaction between ethanol and concentrated sulfuric acid at 383 Kelvin gives ethyl hydrogen sulfate. Let us see. Here we have taken ethanol CH3CH2OH plus HOSO3H, that means H2SO4. That H of sulfuric acid and OH of ethanol, they will release water molecule, and OSO3H will combine with the ethyl group. So what happens? So CH3CH2OSO3H plus water is formed. So this compound is known as ethyl hydrogen sulfate. When ethyl hydrogen sulfate is distilled under reduced pressure, diethyl sulfate is obtained, which is given here. 2 moles of CH3CH2OSO3H gives rise to CH3CH2 whole twice SO4 plus H2SO4. Now we shall discuss about the another property which is known as oxidation of alcohols. Oxidation of alcohol involves the cleavage of both OH and CH bonds, and at the same time there is the formation of a C double bond O bond. For example, here I am given CH, another side OH. So CH bond will be broken, all of you know that, and OH bond will be broken as given by arrow mark, and these two bonds combine together to form C double bond O group. That means one hydrogen molecule will be removed by this process. Primary alcohols are easily oxidized to aldehyde with normal oxidizing agent such as sodium dichromate and sulfuric acid, which yield chromic acid, or with acidified potassium permanganate. The aldehydes are further oxidized under reaction condition to form acids having the same number of carbon atoms as in alcohols. For example, ethanol gives ethanol, then on further oxidation it gives ethanoic acid. Let us see the reaction. I have taken CH3CH2OH. So this is ethanol. When it is treated with the alkaline KMnO4, acidified KMnO4 or acidified K2Cr2O7 or Na2Cr2O7, potassium dichromate or sodium dichromate, the oxygen will come from these oxidizing agents, and the ethanol will combine with the oxygen to form ethanol or acetaldehyde. That means one H from carbon and one H from O will go with the oxygen to form water molecule, and the CH3CH double bond O is formed, which on further oxidation gives CH3C double bond OH. That means the CH bond becomes COH bond. That means O is introduced into CH bond. So ethanoic acid is produced, which is also known as acetic acid. In case controlled oxidation leading to the formation of aldehyde is needed, it can be achieved as follows. Aldehyde must be immediately distilled from the reaction mixture. Students, if you want to stop the reaction at the aldehyde stage and we don't want acid, then what should be done? Aldehyde must be immediately distilled from the reaction mixture. Number 2, the mild oxidizing agent chromic anhydride is uh, in anhydrous medium converts primary alcohol to aldehyde stage only. If you take chromic anhydride, then no acid will be produced, only aldehyde stage will become. A better reagent for the controlled oxidation is pyridium chlorochromate C5HN H5N CrO3Cl. It is abbreviated as PCC. It can be prepared by mixing pyridine, CrO3 and HCl in the presence of dichloromethane acting as a solvent. Another oxidizing agent which can affect controlled oxidation of a primary alcohol to aldehyde is pyridium dichromate with formula C5H5NH2 plus Cr2O7. Students, similarly, the secondary alcohols can be oxidized to ketone by chromic anhydride in anhydrous medium. For example, CH3CCH3HOH. So this is a isopropyl alcohol or propan-2-ol. This is a secondary alcohol. When it undergoes oxidation, then the CH bond becomes COH and COH and that is another COH. Then one water molecule will be removed. So as a result, what formed? CH3CCH3 double bond O is formed, which is known as acetone or propanone. Unlike aldehyde, ketones are resistant to further oxidation. In case it is desired, the stronger oxidizing agent like concentrated nitric acid is required. Actually, the oxidation of a carbon-carbon bond is quite difficult. Therefore, ketones changes to ethanolic form, which is then oxidized. So first you see, so propanone is CH3 double bond O. This is propanone or acetone. First is converted to enolic form, CH3 double bond CH2OH. So that enolic form can undergo oxidation to form ethanoic acid as follows. So tertiary alcohols are quite resistant to oxidation and is carried with concentrated nitric acid or neutral alkaline potassium permanganate. Actually, these are first dehydrated under reaction condition to alkene, which are then oxidized to acids and a lesser number of carbon atoms as follows. You see, here we have taken tertiary butyl alcohol or whose IUPAC name is 2-methyl propan-2-ol. So when concentrated nitric acid is taken, then what happens? The OH and the H of a methyl group will go in the form of water. Then it will give CH3 C double bond CH2 single bond CH3. So it is isobutylene or 2-methyl propene, which on further oxidation gives ketone. Ketone means one propanone. Here for this example, this is a propanone plus carbon dioxide plus water. Then we shall discuss about dehydrogenation reaction. The dehydrogenation of alcohol is carried out with reduced copper at 573 Kelvin. That means 300 degrees centigrade. When alcohols are treated with copper catalyst at 300 degrees centigrade, then the hydrogen molecule is removed from, but two hydrogen atoms of alcohols will be removed to give the product. Primary alcohols upon dehydrogenation form aldehyde. Let us see CH3CH2OH in presence of a copper catalyst at 573 Kelvin. Then what happens? The H of oxygen and H of carbon, the nearby carbon, removed. What happens? A double bond is formed, ethanol or acetaldehyde is produced along with the hydrogen gas. Come to secondary alcohol when dehydrogenated gives ketone CH3CCH3OHH. So H of OH group and H of the carbon which is connected with OH group goes out. So as a result C double bond O is formed. So what is formed? CH3 C double bond O CH3 plus H2. Similarly, tertiary alcohols are not hydrogenated. These are rather dehydrated to alkenes. You see, so CH3C, CH3CH, OH. The carbon containing OH having no hydrogen atoms directly attached to carbon. Therefore, this is CH3, CH3, CH3 attached to carbon. So, the OH of carbon and the H of the CH3 will go in the form of a water molecule. As a result of what happens? CH3C double bond CH2 single bond CH3 is formed. Let us see how we can distinguish between primary, secondary and tertiary alcohols. So one method which is very important method, this is known as Victor Mears test. So that is also known as RBC test, red, blue, colorless test. So primary alcohol will give red color, secondary alcohol will give blue color, and a tertiary alcohol will never give any color. That means it is a colorless. So we can simply say it is RBC test. So the test is completed in the following steps. The given alcohol is first converted to alkyl iodide by reacting with red phosphorus. Students, I am just showing you the reaction of three alcohols. First I have taken primary alcohol RCH2OH, then secondary alcohol R2CHOH, then tertiary alcohol R3COH. So I have reacted with all the alcohols with the red phosphorus and iodine, that means Pi3. So what happens? Alcohol reacts with the Pi3 to give Ri, RCH2I. So in case of a primary, in secondary R2CHI, in tertiary R2CI. The iodoalkanes are formed. So in the second step, the alkyl iodide is converted to corresponding nitro derivatives with silver nitrite or AgNO2. You see, these compounds when react with the silver nitrite AgNO2, then what happens? Then silver alkyl iodide plus AgNO2, then it will give alkyl nitrite, which is given. For primary alcohol, it is RCH2NO2. For secondary alcohol, R2CHNO2. For tertiary alcohol, it is R3CNO2. So what is the difference between three products which is formed? In case of the product formed by primary alcohol, so RCH2, you see the nitro group which is attached to the carbon contain two hydrogen atoms. But in case of a secondary alcohol, the nitro group which is attached to the carbon contain one hydrogen. But in case of a tertiary alcohol, the nitrogen atom by nitro group attached to the carbon which is only connected with the alkyl groups but not having any hydrogen atom. So in the third step, the nitro derivatives is then reacted with nitrous acid. Students, you know that nitrous acid is not available in the laboratory or any market. It can be freshly prepared by reacting sodium nitrite with dilute HCl. And when these nitro groups, nitro derivative of the alcohol is treated with the nitrous acid prepared from sodium nitrite and dilute HCl, and the resulting solution is made alkaline. After reacting with the nitrous acid, if we made alkaline, what happens you see. So we have given nitrous acid HONO, that means HNO2. So HONO if we are giving, then two hydrogen atom of the carbon of the above compound combine with the O of NO. Then what happens you see, RC double bond NOH. So this is called as nitrolic acid. Come to the right side, secondary alcohol. Then RCHNO2. So CH, that means one H. Here HONO. So HO of nitrous acid, H of the nitro derivative will combine to give water. So RCN double bond O. So this is pseudo-nitrol. Come to the right hand side. Since the carbon of the nitro derivative of alcohol has no hydrogen atom, therefore it will not react with the nitrous acid. So I have written no reaction. So when it made alkaline, what coloration obtained? If this compound is given with some sodium hydroxide, then what happens? You see, the primary alcohol gives a blood red color, or if we get blood red color, we can conclude that this compound is a primary alcohol. Similarly, the secondary alcohol will give a blue color, and the tertiary alcohol will give no coloration. So it is a very good test because anybody can identify from the coloration. So one can safely say that this is primary alcohol, or this is secondary alcohol, or this is tertiary alcohol by knowing the color of the reaction mixture. Another test is the Lucas reagent test. Students, I have already told you, in the preparation of alkyl chloride or the reaction of alcohol with HCl in presence of anhydrous zinc chloride. You know that anhydrous zinc chloride is known as Lucas reagent. When it is treated with alcohols, then which alcohol will react faster? The tertiary alcohol will quickly react to form a turbidity or cloudiness at the neck of the test tube. So, if three alcohols are there, one you take three alcohol in one test tube primary alcohol, in second test tube secondary alcohol, and in a third test tube tertiary alcohol, and add anhydrous zinc chloride and HCl to each solution. After adding, you shake it and you will find there will be immediate cloudiness on the neck of the third test tube which contain tertiary alcohol. And the turbidity appears after some time on the near the neck of the second test tube. Therefore, you will find that this is secondary alcohol. But you will find there will be no turbidity on the first test tube, and if you heat, then turbidity will appears, and that is primary alcohols. So this is also another test from which we can identify the primary, secondary, and a tertiary alcohol, and we can distinguish them. Another test is also there, iodoform test, which involves iodine and sodium hydroxide. So from iodoform test, we can also test the primary, secondary, and tertiary alcohols. Students, thank you again, and I think you will understand all the properties of alcohols. So read thoroughly and try to listen the video, because the organic chemistry without whiteboard or blackboard or any rough note is very difficult to teach. Still then I have tried a lot to explain all the things. Thank you. Stay safe.